Hello everybody, my name is Kamala from SMP 3A, Math Group number 7, and today I'm going to be explaining to you guys the things that you need to know before using a clinometer. So there are two things that you need to know before using a clinometer, and those things are your angles of elevation and your angles of depression. But before we define what these are, we have to define first what is a horizon. So, a horizon is basically your line of sight when you're looking straight forward. Or it's basically just for a horizontal line, but in this case, it's your line of sight when you're looking forward. So let's say this is you, and you're looking forward. There is no tilting your head up or down, and this thing is your horizon. Now, what do we do with horizon? What does this have to do with angles of elevation and depression? So basically, an angle of elevation, an angle of elevation is an angle formed by the horizon and the observer's line of sight to something that is above the horizon, and angle of depression is the angle formed by the horizon and the observer's line of sight to something that is below the horizon. Now, what does this mean? So let's say there are two things. There are things that is above and below you, and you want to look at them. When you tilt your head up or down, your line of sight changes from this horizontal line to this one when you're looking up, and this one when you're looking down. Now, this thing, let's say this is x degrees, is your angle of elevation, since it is formed by the horizon and your line of sight to something that is above this horizon. Your angle of depression, let's say 9y degrees, is formed by this horizon and your line of sight to this thing. Now, another example. Let's say that there is a building and there are two people here. Two people, one at the top of the building and another person down here. Let's say these people are Steven and Nathanael. Steven and Nathanael look at each other. Now, can you tell me which one is the angle of the which person has an angle of elevation when looking at the other person, and which one has an angle of depression? To know this, we first have to draw their respective horizons. Nathanael looks straight ahead, and Steven also looks straight ahead. Now, we can see that Steven's one, because he's looking up, this is an angle of elevation, just like this one. Let's say this is x degrees. And Nathanael, since he's looking down, has this one, also x degrees, has an angle of depression. Now, something that some people will get wrong is that they will assume that this one is their angle of depression, where in fact this one is not your angle of depression, but this one is. And that's basically all there is to it. But before I leave you, I'll give you guys one fun fact. And the fun fact is that these two angles, an angle of depression and elevation from one singular line, these two will always be congruent, because if you extend these two, it's as if a transversal line has drawn through these two things, and these ones are interior angles. So these two angles are congruent.
Now I'm going to show you how to make a clinometer. First, you need a protractor, a cardboard, a piece of paper, and a string about this long. So the first thing you need to do is you put the protractor in here. Make sure it's straight. Okay. So first, make sure it is straight. Okay, and then you take the string and then you put it in here. Like this. Make sure it's straight also, that it is 90 degrees. And then you roll a paper. Make sure it is big enough so you can see through. And then you put it in here at the top of the protractor. And then you get a coin. You stick it to the string in here. Oops, sorry. Like this. And it's done. Easy.
Today I'm going to show you how to use clinometer. So that is the wall that I'm going to measure with the clinometer. And my distance between the wall is 210 centimeter. One of that ceramic is 40 centimeter except the small one that is 10 centimeter. The clinometer into your eye level, then aim to the top of the things that you're going to measure. So this is the solution for the height of the wall.